Alright, your homework should have already been turned in and graded and discussed. And now you're working on the warm-up, which is in the blue homework helper book underneath your desk. It's page 87, 25 to 28. Give you a couple more minutes. Each question, make sure you read the direction to identify what they are asking you to find. Okay, give you maybe 3 minutes to finish this up. Whenever it's done, then we will start. Alright, so if I'm looking at page 87, the first question, 25, says identify the domain and range of the following relation. So again, domain and range, those are some keywords we need to be able to identify. Domains represent what values? Okay, these are the x values. Domains are x's, ranges are y's. So if I'm looking at the ordered pair that they give me, it looks like the domains are 3, 3, 3, 3, 3. Now since they're all listed as 3's, it's the same number. So I'm just going to list 3 one time. And the ranges here are the y values, 7, 8, -2, 4, and 1. So I'm going to go ahead and list those out. 7, 8, -2, 4, and 1, and that's all. That's all they wanted to have me do, was identify the domain and range. 26. Use a mapping diagram to determine whether a relation is a function or not. So again, mapping diagram, you should have drawn your two circles, or ovals. This first one represents the x values, the second one represents the y values. So if I'm looking at the ordered pairs, I'm identifying the x's and the y's. So the x's are 6, 5, 1, and 7. So 6, 5, 1, and 7 will go in the x bubble. The y values are -7, -8, 4, and -7 is already listed there, so I don't need to list it again. So now the mapping diagram, to show that these are actually ordered pairs, I have to draw a line to show the relationship between the x and the y variable. So this first ordered pair is 6, -7, so I'm going to go ahead and draw a line or an arrow from 6 to -7. The second one is 5, -8. Third one is 1, 4. And the last one is 7, -7. So I'm going to draw a line that goes back up to the -7. And the question asked us to determine whether the relation is a function or not. So if I'm looking at my x's, because again we have to look at the x to determine if it's a relation or not, or function or not, I notice that every single number has one arrow coming from it. So this would be yes, it's a function. Now we don't care about how there's two numbers going to the -7y value. We're only concentrated on the x values. Since there's only 1, 6, 1, 5, 1, 1, and 1, 7, then everything has one x value, so it would be considered a function. Number 27. They're asking us if these points make a function, and they want us to graph it and use the vertical line test. So I'm going to go ahead and list the points out first. -4, 4, 0, -4, +4, 4. Right away I can determine if it's a function or not, because I can look at the x values. I have -4, 0, and 4. So far it looks like it's a function. However, they want us to graph this and use the vertical line test to determine. So I'm going to go ahead and make 4 dashes on each side, or on each axis. Doesn't need to be perfect. This first point is -4, 4. So I'm going to go over -4, 1, 2, 3, 4, and up 4. This one's 0, -4, so I'm going to stay on the 0 on the x, and I'm going to go down 4. And then the last one is over to the right 4, and up 4. Okay, so those are my 3 points that they give me. Now if I perform the vertical line test, I'll draw a vertical line through each of these points that they give me. And it looks like there's only one point on each line, so this would be considered a function. And then the last question, 28, is multiple choice. It says, what is the domain of the relation? So again, domains are the x's. So I'm looking for the x values in these ordered pairs, and what they are is -2, 0, 2, and 4. So -2, 0, 2, and 4, it looks like A is the correct answer. So A is the answer. Now I want you to look at the other choices just because this helps us determine what the other things are. Where'd they come up with the answers for B? -1, 0, 1, and 2. What are those values? Those are our ranges, or our y values. So A was talking about the domains, B is talking about the ranges, and then the other ones are just sort of all over the place, so I'm not sure how you would have gotten C or D. So make sure you remember D for domains are the x's, first number in the ordered pair. Ranges are the y values, which are the second number in the ordered pair. Okay, so that's just a recap of what we've been working on with if it's a function or not. Today we're going to determine if it's linear or not. And again, this is review from last year's 7th grade pre-AP course. So on the next page in your journal, go ahead and label that linear versus non-linear. Today is September 22nd, 2016. Don't forget about the number page. And we're going to put that into our table of contents. So linear versus nonlinear, this is 39 for me. I did cross off independent versus dependent, so you can cross that out. We're not going to talk about that. But again, we should be up to linear versus nonlinear. So take a second to head your journal, and then we will begin when everyone's ready. Okay, so first of all, linear. Okay, this was talked about in your 7th grade pre-AP course pretty often because this is huge. Okay, this is about 33% of the questions on the EOC deal with linear, if not more than that. So let's talk about what a linear function is. Now, one way that I remember linear function is it actually has in the word linear the word line. Okay, so this tells us that whatever points there are, okay, that make this function, it's going to make a straight line. Okay, so linear functions make a straight line. If it's curved or if it's zigzagged or anything like that where it changes directions, that's not linear. It just makes one straight line that's continuous. Now, who remembers the formula for linear functions that you learned last year? What I want you to do is flip back to the cover, your cover, and the formula chart that we taped in, probably on the second day of school. Okay, notice the third section where it says linear equations. Which one of these equations looks familiar to you? You should know two of them for sure. Okay, this first one is what you learned last year as the linear equation, y equals mx plus b, which we're going to talk about today. But you should also know the slope of a line with picking 2 points to figure out the slope. And we're going to discuss all of this in the next couple weeks. But the main thing that you should be familiar with already is y is equal to mx plus b. So let's go ahead and write that down. Y equals mx plus b. They're all lowercase. And let's talk about each letter when it comes to this formula. So the first thing I want to talk about is the m. What do you remember about the m? What did that represent? Okay, you should have said that's the slope. Or you might have learned it as the rate of change. And your teachers could have used just rock, rate of change, rock. Now I'm not sure exactly why they chose m, but this is one way that I remember that the m represents the slope. Okay, is if you actually draw a capital M, you can make it look like a ski mountain, like a mountain. Okay, and you usually ski the slopes of a mountain. So that's how I remember that M represents the slope. Okay, now the B. The B can be positive or negative. Okay, and that represents our y-intercept, where it crosses over the y-axis. Now you also, I've heard other teachers use this, it's where the starting point is on the y-axis. So wherever it crosses over the y-axis, that's the B. And one way I remember that, and I teach my on level that, is where do you usually start your day? You can say in bed, or you can say brushing your teeth or breakfast. Okay, so the starting point where it crosses over that y-axis is the y-intercept. Now the last couple of days we've talked about the x and the y with if it's a function or not, and we know that some of these words, there's other words that represent the x and the y values. So remember the x values, what's another name for the x values? You should have said domains. We also call them input values and independent values or variables. And then the y's, another name for the y values are the ranges, which we talked about in our warm-up today. They're the output values. Once we plug in the x value, we get an output. And these are the dependent variables. Okay, so this is just basic information that you guys should know already, but we're going to move on to a little bit more algebra using this formula. So, what you guys have done last year is, does it always have to have a y-intercept? Does this always have to be a number? I said it could be positive or negative, but could it be 0? Yeah, it is. And if it is 0, how many people remember what that is? That name is? That means it goes through the origins. That means it's proportional. So sometimes we don't even have a b here. Okay, and sometimes the slope here is just 1, so we don't really need to write the 1 in front. So what you're going to be learning for every function that we learned in algebra is that they come from a parent function. So we're going to write this down. All linear functions come from the parent function of, and we're going to write the parent function for linear. Now again, as you're writing that down, think of a parent function. Okay, you guys are all kids. You came from your parents, so you have a lot of traits and characteristics just like your parents, which means that you take away from them. Parent function is the most simplest form of the function. So you take away some characteristics from your parents, which means your parents are the simplest form, and then you might have some extra, characteristics from your other parent and so forth. So it's the simplest form for all types of functions. So sometimes we have the b, sometimes we don't. So technically it could just be y equals mx. But remember I just said if the slope is 1, do I necessarily need to put a 1 there in front of the x value? No. So that's why our parent function for all linear functions is just y is equal to x. And I want you to highlight parent function y is equal to x. Now again, this is the same thing as our formula. It's just the b here is 0 because it would be x plus 0. And what coefficient is sitting in front of the x? How many x's do I have? That would be 1. So every parent function for linear equations comes from the y is equal to x. If I define parent function, I would define that as the simplest form of a family of functions. So everything comes from this function. Now what I want you to do is let's plug this parent function into our graph on our calculator. So to graph any parent function, go ahead and turn your calculator on. When we graph any function at all, notice where it says y equals at the top. Okay, it's the first gray button. Push that. If you have anything, you can clear it. So just move your arrow down, push clear. Now we want to be on the y1. What I want you to do, y1 just means y. Okay, so y equals, and we're going to put x. X variable is right next to the alpha button. So I'm going to push x there. And let's go ahead and graph this to see what this parent function looks like. Now we know it's linear, so it should make a straight line. Now my graph has a little bit more stuff to it, so I'm going to have to clear that out. So yours should look like this. Now if you notice, where does the y-intercept? Where does it cross over the y-axis? It's at 0, which again, the y-intercept for this parent function is 0. And if you notice, I'm going up 1 over 1, up 1 over 1. That's my slope. I'm going up. The rate of change is going up by 1 for every domain value. Okay? So, when we're coming to today, we identified whether it's a function or not the last 2 days. Now we're going to identify if it's linear or not. So, we're going to make our t-chart linear and not linear. And just like function or not, you're going to have to identify it from different representations, whether it's ordered pairs, equations, graphs, tables, anything like that. So we're going to start off with equations. How to identify if it's linear or not from an equation. Now, what we're looking for to determine if it's linear or not from an equation is it has to have this form. Whether it has the m or the b attached, the x variable has to have an exponent of 1. So, if I write one, this is in y equals mx plus b, let's say y equals 3x plus 2. Okay, again it has the y with an exponent of 1 equals x with an exponent of 1. It has a starting point or a y-intercept of 2 and a slope of a positive 3. But the x variable has an exponent of 1. Now it doesn't need to have the y-intercept. This is also linear because it's y equals x. Sometimes I could just have y equals x plus 2. Okay, plus a y-intercept. But no matter what, it has the parent function in it. And sometimes it doesn't have to be exactly in that order, y equals mx plus b. It could be y is equal to, let's say, 6 minus 2x, where they put the y-intercept first, and then they put the slope. But no matter what, it has the parent function, y is equal to x. So what you have to remember when it comes to equations, on identifying if it's linear or not, put a triple star actually, because this is important, is that the x value has an exponent or power of 1. We don't need to put that there, but it's there. I'm going to go ahead and highlight that because that's very, very important for us to remember. Now another way of checking this is using our calculator. If these are all linear, that means they should make a straight continuous line. So go back to your y equals. We're going to clear the parent function, and let's type in this first one. So you're going to write 3, the x, right by the alpha button, plus 2. It should look like this. Check your neighbors or ask your neighbor if you need help. Let's go ahead and graph that. Okay, it's a linear line, has a y-intercept of 2, and it's a positive slope because it's going up 3 over 1. Go back to your y equals. Let's type in the last one we wrote down. 6 minus 2x. 6 minus 2x. I'm going to go ahead and graph that. Again, it's linear. It makes a straight line. The y-intercept here is positive 6. It's going down 2 over 6. That's why the slope's negative 2. Everything here makes a straight line. So what would make not straight line? Okay, it could look like this. Y is equal to x squared. Okay, this is our parent function for linear, but since it has an exponent of 2, that graph is going to look like this. And you don't have to do this, just look up here, okay, where it's x squared. It's going to make a U shape. It's not linear, it does not make a straight line. Or it could have extra stuff where it's y equals the absolute value of x. Remember those bars? Where that talks about the distance away from 0. And then maybe another one could be y is equal to the square root of x plus 3. Okay, it has to only have x with an exponent of 1. No absolute value symbols, no square roots. Okay, all of these graphs would not make a straight line on your calculator. Okay, so again, once we identify equation, we can check it with our calculator for the graph, but let's draw some pictures of what a linear graph looks like and a nonlinear graph looks like. So what I want you to do is I want you to draw 4 quadrants. It's sort of small, I don't have a lot of room. At least on the linear side. Now there's really 4 different types of graphs that could possibly be linear. Okay, the first one is our parent function, and what that looks like is it goes through the origin and goes up from left to right. Okay, this is called a positive slope or a positive graph. And the way that I remember that is if I'm reading a book, I usually read a book left to right. So if I read this graph left to right, it's going up, which is positive. Okay, the other type of linear would be going down from left to right. And what do you think that slope would represent? That would be a negative graph or negative slope. And sometimes my students think of creative ways on how to remember that. Again, from left to right it's going down, so that's negative. But if you make like dotted lines, make sort of an N shape. Look up here. Okay, see N for negative, so that would be considered a negative slope. The next 2 you're going to have to memorize. This is considered linear because it makes a straight line, doesn't change directions. And what this is called is a zero slope. It's not going up or down, it's just a zero slope. Okay, now what type of line is this? Is this a vertical line or horizontal line? It's a horizontal line. So whenever you see a horizontal line, you know it's a zero slope. Now the reason why is because horizontal. I have a capital Z. That's how I remember it. Horizontal line has a zero slope. And the last type of linear graph you might see is a vertical line. A vertical line has a slope that is undefined, and we're going to talk about that some more when we get into slopes. And the way that I remember that an undefined slope is a vertical line is because this V looks a lot like the U and undefined. So that's how I remember it. You might have a better way of remembering, but the U in undefined looks a lot like the V in vertical. So these are the 4 types of graphs that would show that it's linear, just because it's based off of their slopes. Now, trick question. Are all of these functions? Remember, how do you identify a function from a graph? I would be able to draw a vertical line test. So this one would be a function. This negative slope, a vertical line through all these points, would be a function. Horizontal, that would also be a function. But when it comes to this vertical line, or undefined slope, all of those points are on that line. This is the only one that's not a function. Go ahead and write that down, because that's how they can trick you when it comes to the EOC. Is this one is linear, but it's not a function. Now, what are some graphs that are not functions? Now, we typed in, or I showed you, y equals x squared. So if I pull my graph up again, this is y equals x squared. That's considered a non-function. So I'm going to go ahead and draw that U shape. It's not a straight line, so that would be considered not a function. This is called a quadratic function. Okay, if I had z for Zorro, they're all straight lines, right? So is this a function? No, it's still not a function because these change directions. I can't have a straight line change direction, then change again. Okay? And then anything else, I don't know, anything at all. Anything curved with lines, if it changes directions, that would be considered a non-function. Okay, so you're going to have to identify if it's linear or not from an equation, from a graph, and the last thing is from a table. So I'm going to put linear and not linear. Make my T-chart again. And now we are going to talk about from a table. So let's start off with a linear table. Go ahead and make your XY table. Go ahead and fill these points in. The domains are 0, 1, 2, and 3. The y values or the ranges are -5, 0, 5, and 10. Now, to determine if this is linear or not, we have to look and see if the x and the y values have a constant rate of change. Okay, so that's what we're looking for. So I like to draw these little carets to show the difference between all these points. So on the x side, or the domains, what's happening from 0 to 1? What happened? I added 1. From 1 to 2, I added 1. 2 to 3, I added 1. If all of those are constant, okay, then so far so good. But we have to check the y values as well. So I'm drawing my carets for the y values. From -5 to 0, I went up 5. From 0 to 5, I went up 5. From 5 to 10, I went up 5. So in this case, if both the x and the y values have a constant rate of change, it is linear. So we're going to put double stars here and put if the x values have a constant means the same rate of change, and the y values have a constant rate of change, then it's considered linear. So an example of a nonlinear table, go ahead and draw your X and your Y table. Let's do 3, 6, 9, and 12 for the domains, and 1, 4, 5, and 7 for the ranges. So again, if I'm looking at the X values, I'm looking for the rate of change. 3 to 6, I went up 3. 6 to 9, I went up 3. 9 to 12, I went up 3. So far it's looking linear, but we have to make sure that the Y values also have a constant rate of change. From 1 to 4, I went up 3. From 4 to 5, I went up 1. From 5 to 7, I went up 2. Okay, if I notice, all of these for the Y's are not constant. Okay, so this would be considered not linear because why? What would you write? I would write because the Y values don't have a constant rate of change. Okay, so I'm going to give you another table, and I want you to tell me if it's a function or not, and if it's linear or not. So here's an example of your XY table. Let's do 1, 2, 4, 8, 16, 2, 4, 6, 8, and 10. And what I want you to tell me is if it's a function or not. And the second thing I want you to tell me if it's linear or not. So go ahead and take a second to work on that. I want to see your carets. So make sure you draw your carets every single time to show me what happened. And then when everyone's close to being finished up, we will push play and move forward. So if I look at the X values here, 1 to 2, I'm going up 1. 2 to 4, I'm going up 2. 4 to 8, I'm going up 4. 8 to 16, I'm going up 8. So far it's not constant, but some of you might have noticed that instead of adding, 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. So technically here, we are multiplying each one by 2. But when I'm adding or subtracting, it's going up differently. Let's check the Y values. Y values go up 2, up 2, up 2, and up 2. So far the Y values make it linear. But what about this? Can I multiply by the same thing? Does that still make it linear? Or is it only when I add or subtract? And what you have to remember is that you have to add or subtract when it comes to the constant rate of changes. So it's not being multiplied. That's a whole different type of function. We're not looking for that. We're looking at the constant rate of change if it's being added or subtracted and if it's the same. So function again. Function means the X values are all different. Are all the X values different? Yes. So you should have found out that it's definitely a function. Is it linear or not? Well, if I look at my carets, 1, 2, 4, and 8, is that constant for the X values? No. So this would not be linear. This would make some other type of graph. Okay, so the last thing I want you to put in your notes, and you can put a triple star for this one, when it comes to the table, these are called our first differences, which are the carets that we drew. They need to have a constant rate of change for the X and Y values being added or subtracted. go ahead and highlight that. So when I'm looking for the constant rate of change for the x's and the y's, I'm looking to see if it's the same thing being added or subtracted. If it's the same for the x and the y's, or they're going up or down by the same on each side, then it would be considered linear. Alright, so for your assignment today, for your homework, we're going to go through this pretty quick so you can get started before the bell rings. Go ahead and get out a separate piece of paper and head that, just like we always do, with your name. This is 5-1 worksheet, and you'll see that at the top when you get it. Today is September 22nd, and your period Friday. Go ahead and you can fold that in half. Now we're not going to use this until the back side. So after you had that, someone should be passing out the paper. And once you get that paper, look up here, or just pay attention right now. 1 and 2, it says identify whether each graph represents a function, explain, and if it does make a function, is it linear? So you have to write out if it's a function, if it is it linear? Okay, so for both of those, make sure you have both of those questions answered. Number 3, it says which set of ordered pairs satisfies a linear function? So this would be both. It has to be a function and it has to be linear. So what I did for you is I sort of set up an XY table. I want you to put those points into the XY table. Show me your carets and identify if it's a linear function or not. On the back is when you're going to need that piece of paper. Okay, for 8 through 25, it says determine whether each table, graph, or equation represents a linear or nonlinear function. So, if I'm looking at 8, okay, I'm going to put 8 here. Now notice, all of these tables are horizontal. I want you to rewrite every table vertically, so let's do the first one together. Okay, the x's are 3, 6, 9, and 12. And the y values are 12, 10, 8, and 6. Now determine if it's a linear function or not. First of all, function means all the x's are different, which they are. And now I'm going to determine if it's linear based off of the constant rate of change. So I want to see your carets for each one, x and y. 3 to 6, I'm adding 3. 6 to 9, adding 3. 9 to 12, I add 3. So far, so good. If I look at the y values of my carets, I have, sorry, this is minus 2. 12 to 10 is minus 2. 10 minus 2 is 8. 8 minus 2 is 6. Since they're both constant, okay, that means that, yes, this is a function. So on your paper, I want you to write linear, linear or not linear, circle it, and then I want you to write linear next to the number 8. You're going to do that for 9, 10, 11, 12, and 13. Redraw the table so it's vertical. Number 14 through 19, you have to show me from the graph if it's linear or not. So again, just write linear or not right underneath the graphs. And then 20 through 25 is they give you the equation. You can use your calculator to check that. Again, but you should remember what makes it linear or not. 26 and 27 are word problems, so read those carefully. And tomorrow you'll turn in your work paper stapled to the back of this paper. Make sure your name's on it, and we'll grade it first thing. Have a great day.